Math 7 students, we're here again. We're reviewing fractions. Today is the reducing fractions review. So, let's talk about equivalent fractions for just a second. If I have a whole, so this circle is one whole, and I divide that whole into two parts, that is the fraction 1/2 if I have half of the whole. So I have this half of the whole, that's the fraction 1/2, and so there you go. But what if I divide this into 4 equal parts, like so? Now instead of having one, I still have 1/2, not instead of, I still have 1/2, but it's the same as 2/4. And if I divide it into 8 equal parts, okay, now I have 4/8 and 8/16 and 16/32. One thing that I want you to notice in the equivalent fractions, what are the top and bottom multiplied by in each progression, in each new fraction?
They get higher.
They get higher, but what is the number that they're multiplied by?
2.
Okay, they're multiplied by 2. So 1 times 2 is 2, and 2 times 2 is 4. 2 times 2 is 4, and 4 times 2 is 8. And that 2 stays consistent all the way through. So we could multiply 16 by 2 and end up with
32.
32 and 32 by 2 and end up with 64. Okay? So these are all equivalent fractions. They're the same amount. We're just dividing this whole into smaller and smaller equivalent pieces. But this, that we have half of it, doesn't change. So these are equivalent fractions. This is another set of equivalent fractions. What are the top and bottom of each fraction multiplied by as we progress to get bigger and bigger numbers? What is this? It's called the scale factor.
3.
3, yeah. 3 times 3 is 9, and 5 times 3 is 15. 9 times 3 is 27, and 15 times 3 is 45. And 27 times 3 is 81, and 45 times 3 is 135.
Then 81 times 3 is...
Okay? And then you could keep going on forever and ever and ever. And the fraction, all the fractions will be equivalent. So when you're reducing fractions, what you're really doing is you're finding the smallest equivalent fraction that you can to these fractions. Okay? So I have some examples here to show you how to do that, how to find that smallest fraction. The easiest thing to do is to find a number that the top and bottom can both be divided evenly by. So, in this fraction, what can the top and bottom easily? You can divide the top and bottom both by what number?
5.
5. Okay? So if I divide the top and bottom by 5, okay, what's 45 divided by 5?
9.
9.
How do you know that?
And what's 100 divided by 5?
25.
Nope.
50.
Nope.
20.
20.
Oh.
Okay? So the equivalent fraction is 9/20. Is there anything that you can divide the top and bottom evenly by that's not 1?
9's prime and 20's even, so you can't do that.
Okay? 9's not prime, it's odd.
Odd.
It's odd, but it's not prime. But these two, you can't divide anymore, so that is your smallest fraction. Okay? In this one, what is a number that you can easily divide both of them by?
2.
Okay? 2. So I divide the top by 2 and the bottom by 2. 2 divided by 2 is... Say it louder.
1.
There you go. Say it like you mean it. Say it with authority. Okay?
1.
1. 38 divided by 2 is?
19.
19. And we have 1/19. And that's as far as you can reduce
you can
that.
never go
Yeah.
once.
Yeah, once you get to 1 on the top or bottom, you can't reduce anymore. Okay? This one's a little bit more tricky. Okay, you've got 42/77. 77's odd, so you can't divide by 2. You can't divide either of these by 5, but there is a number that you can divide them both by. Say it louder. Who said it?
You said it.
He said it. Okay, go ahead.
7!
7. Yeah, you can divide the top and bottom both by 7. What's 42 divided by 7?
6.
6. And 77 divided by 7 is 11. So you've got 6 over 11 is your smallest fraction. Okay, this one's even a little bit more tricky. Because you've got this that's an even number, but it doesn't end in 0, so you can't divide by 5, but you can't divide this by 2. So, let's try a couple of numbers. Let's try 4. Maybe you can divide them both by 4. So, 36 divided by 4
9.
I mean, it works. So.
is 9. Okay? And 135 divided by 4, that would be 3, 12, 1, 15. Does that work?
No.
Okay? So that doesn't work. So we're doing a little bit of guessing and checking here. So we tried 4 already, right? Let's try 3. I know some of you have the answer, but I want to go through the process of guessing and checking. Okay? So let's try 3. So 3 into 36 is 12. So that works. 3 into 1, 35. That would go 4 times and be 1. Ooh, look at that. It works. 12
But it's got leftover though.
over 45. What's the leftover?
15.
5 times 3 is 15.
0. He's right.
There's no remainder. Okay? So 12 over 45. Now the question is, can I reduce this even more? How so?
3 can go into 45, 3 can go into 12.
Okay? So let's try that. 3 into 12 is 4. And 3 into 45,
15.
that's once. Look at that. So can you reduce that anymore?
No.
Okay, you can't reduce that anymore. So that is going to be your final fraction. So this one was a little more challenging. We had to guess and check. We had to try something and see if it worked. See if they both, the top and the bottom, were divisible by that number. We tried 4, it didn't work. We tried 3, it did work. And these are all equivalent fractions like we talked about in the beginning. So, reducing fractions. The key is finding which number the top and bottom can both be divided by and come out with a whole number, and then you keep doing that process until you can't reduce them anymore. You find the smallest equivalent fraction, and that is how you